L.6.4, where we're adding and subtracting polynomials. We're going to use the same steps we did yesterday. We're going to realize that polynomials are shown by, they're in parentheses. We're going to change any subtraction within those parentheses, within the polynomials themselves. We're going to change any subtraction to add the opposite. If it's an addition of polynomials, we get to just ditch the parentheses after that. If it's not addition, we're going to change the subtraction to add the opposite, and we'll be able to get rid of parentheses that way. And then we also talked about there are a couple of different ways you can add. You can either use the vertical format or you can use the horizontal. We are going to practice both of them together right now because the ones we're practicing today, what turns out is we don't have exact like terms in the polynomials. So let's look at number one. Do we have any subtraction within the polynomials to change? Yes, we do. So let's go ahead. Go ahead and do that on your papers first. Get the subtraction within each of the polynomials changed to add the opposite. If you want, if there's not a coefficient there and you want to put the coefficient 1 in front of anything, feel free to do that. You don't have to. If it does, you don't need to. This one is addition of polynomials, so we don't need to take care of changing another subtraction, so we can go right to our vertical format. When we're adding, it does not matter which order we do it in, so you get to make the call, but here's what I'm going to suggest you do, okay? I'm going to suggest you take the polynomial when you're deciding, you know what, I want to be different. When you're deciding which one to put on the top in your vertical format, take the one of the highest degree. So which of these two polynomials is the higher degree polynomial? The first one or the second one? Brighton?
The first one.
The first one. What is its degree?
3.
3. What's the degree of the second polynomial? Cameron? 2. So the one of higher degree is the first one. So when we're writing it down, here's what we want to do. As we're writing it down, we want to be able to go from the highest, it's given to us in standard form, that's good news. When we are, if it's not, we want to put them in standard form. But for now, I think they're kind of kind to us and they just give them to us in standard form. But we want to put them down in descending order, the terms. If there are any terms that are missing, or in other words, the next term down would be x squares. Well, we have some x squares. They're not missing. But then the next term of a polynomial in standard form as you're going in descending order down would be x's. Do we have any x's? No. So what do we use when we don't have something in vertical format? Placeholders. Yeah, we use, so we say there are 0 x's plus our constant, which is -3. Okay.
Recursion on the box up in the right.
That could be part of it. Yes, that's the issue, isn't it? Okay. Thank you. So now we'll line up underneath that our other polynomial. Okay, so when we look at our other polynomial, we'll put a big plus sign over here showing that we're going to add. When we look at our other polynomial, it's in standard form, but it doesn't start with what? X to the third powers. So we're going to have to use a placeholder, a 0x cubed. It does have x squares. We have a 4x squared. It does have x's. And it does have a constant. And we should be lining these up nice and vertical columns to make it easy to add them. Okay.
This is Leanne.
Yes?
Will you have Trey transfer them to the office, please?
I will. Okay, so 2x cubed plus 0x cubed. Class?
2x cubed.
Class.
2x.
Thank you. 1x squared plus 4x squared.
5x squared.
5x squared. Plus 0x plus negative 1x. Negative 1x or negative x. Negative 3 plus 1.
-2.
Negative 2. Okay. Is that how we would see that answer in an answer bank?
No.
No, it needs to be
Clean up.
cleaned up. Okay, so we're gonna clean it up and we're gonna circle that answer because that would be the answer that would be in a multiple choice answer bank for us to choose from. Okay, so that's doing it vertically. We have to use placeholders. When we do it horizontally, now we are going to, that's right, we always, when we're doing it horizontally, we've already done the changing subtraction to add the opposite, so we can just ditch the parentheses right away. So let's write it down, just all the terms with no parentheses around them anymore. Okay, instead of placeholders, when we're doing it horizontally, what do? We just rearrange them, yeah. We put them in groups of like terms, starting with the highest degree. So we already determined that 2x cubed was the highest degree. And we look to see, are there any other x cubes to group with it? No, so we can move on and we say, okay, x squareds would be next. So x squareds, there's a 1x squared, and further down the line, there's a plus 4x squared. Next, we would move on to x's. We got to go almost to the end to find that we have plus a negative 1x. And if as you're going along, underlining or boxing them as you go along works best for you, that might be the way to do it, to kind of keep it so that you can keep track of it. There's no other x's to be put with that negative 1x. So it's its own little group, plus our negative 3, plus our 1. Okay. So we can, when we're doing it horizontally, we can ditch the parentheses. We rearrange the terms. And now we combine those like terms. So we have no other x cubes to combine with that 2x cubed. And then we combine our x squares. We have 5 of them all together. We don't have anything to add with our negative 1x. And we end up with the same result we did when we added them vertically. And again, we have an answer that needs to be cleaned up. So we will clean it up. Showing it the way it would be in an answer bank. Okay, doing these in the homework, let me see a show of hands. How many of you use the vertical format the majority of the time? The vertical format. Okay, and horizontal, you have to go for one or the other. I need a hand. I need to see a hand. Some of you people are like so unengaged here. Okay, let's try this again. Okay, there are 16 of you in here, so I should be able to add the 2 sets of hands I see, and it should come to 16. Okay. Vertical format was the preference choice you made. You think that that was the one you used more? Okay, that was definitely the majority. Okay, horizontal format. Girls up here, did I see your hand for anything? Yeah. What was it? You were both vertical? Okay, I just don't remember. Okay, thanks. Okay, so vertical format seems to be the more popular of the two. Okay, I agree. I like the vertical better too. But which one should you do? The one that you're most successful with. Which one works best for your brain? Which one works for you? Okay? Okay, look at, what's the difference in this next one versus what we just have been doing yesterday and now today? Josh?
There's 3 equations.
Okay, what are those called? They're not equations. What are they?
Thanks.
They start with, that's a P. It's a P word. Polynomials, yeah. We have 3 polynomials this time instead of just 2. Okay, that doesn't change anything. We can still do it the same way. Okay? Cameron?
There's adding and subtraction.
but there's adding and subtraction. So we're still gonna follow the same process. Our process is change any subtraction within each polynomial first. So let's do that first. Insert ones if you need ones in front of things, whatever is going to work for you. But you have to change. I want you to change. I already saw some people today that thought they could be successful without it, and they weren't. So let's change our subtraction to add the opposite first inside the polynomials. We're not changing that one right now. Okay. So we have x squared plus negative 1, that polynomial. From it, we're supposed to subtract 3x plus 2, that polynomial. And then, to that, we're supposed to add the third polynomial, 2x squared plus negative 4x. So when we change this subtraction that we're seeing right here in our next step, we only have to subtract this. Okay? So we're only going to change the polynomial that needs to be subtracted to each of its terms to its opposite. So let's take care of, we don't need to change the first one. We're going to change our subtraction to addition. And 3x plus 2, both terms to their opposite. So what's it going to be?
Negative 3x plus negative 2.
And negative 3x plus negative 2. And then we'll bring down our other addition. We don't change anything here because it's addition. So we'll leave it. Okay. Now I do want you to learn how to do the vertical format for this, okay? When you have 3, have you ever had to add 3 numbers vertically before without a calculator? Yeah. And we can line them up, still one above and below the other, and we just have 3 things to, 3 ones places to add together, and tens and etc. So we can do the same thing here. Okay, which polynomial is of the highest degree? What's the highest degree polynomial we have here? Degree what? 2. Okay, so the first one is of degree 2, and so is the last one. So it doesn't matter which one we start with, but we're going to start with one of them. Okay, let's just start with the first one. So x squared plus what?
2x squared.
No, right here.
Negative 1.
No. We need a placeholder. What's missing?
0.
The x's are missing. We need a 0x in there. And then we can do our constant. So, you know what? If it starts with x to the 6th power, then the next one down would be x to the 5th. The next one down would be x to the 4th. The next one down would be x to the 3rd. The next one down would be x to the 2nd. The next one down would be x, which is x to the 1st. And the last would be the constant. So we need to put those placeholders in there, okay? Because now look at our next polynomial. Negative 3x plus negative 2. What's missing in that one?
X squared.
The x squareds are missing. So I'm gonna put a 1 in front of that one. We have a 0x squared plus negative 3x plus negative 2. In other words, vertically our like terms should be lining up. And then our last one. We have the x squareds. We have some x's. What don't we have? A constant. Okay, go ahead and add that up, see what the sum of those 3 polynomials becomes. What should it be?
3.
Good catch. And I legitimately made the mistake. I'm not going to lie and say to you, oh, I did that to see if you could catch me. No, I did it wrong. So 1 plus 2 plus 0 is 3. Okay, good challenge there. Any other challenge you want to make, Emerson?
I'm confused on how and when to put the 0
When to put the placeholders in? Okay. Well, how we decide when we do or don't, I think maybe the thing to do is first of all talk about if you have a polynomial of degree 4, let's say, and I'm just going to use just a basic, what we would call the parent function. If we have a degree 4 polynomial, we would have x to the 4th, x to the 3rd, x squared, followed by x's, followed by a constant. Well, I'll just use 1, okay? So this has every term possible for a degree 4 polynomial. That's really what we just said. So because it has every term possible, see what's happening? We have a 4, 3, 2, invisible 1, right? And this one is really x to the 0 power, right? Okay, so if any of those are missing, that's where you want to put a placeholder. So if we were adding the polynomial x to the 4th power plus 2x squared plus 3, how many placeholders would that one need? It would need 2. It would need some x cubes. It's missing those, right? And it's missing the x term. So we would need a placeholder there. So that's how we decide where to put placeholders. In other words, if there are, because some of the other polynomials might have those, and then we would not have, we need some like terms to add with them in vertical format. The other choice you have, I almost hate to give you this choice, but if putting placeholders in is difficult for you, the other choice we really could do is, let me get this out of here, we could not put the placeholders in and just leave a space there. But then you got to make sure you leave the space so that you're going to have the column. So you could leave that space in that column empty. But I'm not sure if you guys would be able to, that would work for you or not. So here we would leave this empty. We wouldn't have that there. We would just move it over like that. And here we would not have this here. Okay, so it's kind of like though, if we're adding 107 with 291 with 32, can we put a placeholder here? Or could we put 0? Because there are no hundreds, right? That's really what we're doing. If I take this away and I have a 1 here, could I put placeholders here? Yes, I could put a 0 in the tens place, and I could put a 0 in the hundreds place. It's okay. It's just that we're, and sometimes we have to have a 0 there because it's not just a placeholder, it's saying there are 0 tens because there are also hundreds. So, I don't know, it's kind of just one of those things you'll kind of get used to it, that polynomials can have, just like we have ones, tens, hundreds, thousands, 10,000s in numbers, we have constants, x's, x squareds, x cubes, x to the 4th.
But how do you know it should be placed there in the equation?
How do you know in the expression, in the polynomial, it should be placed there? Because if I lined it up like this, Emerson, okay, I gotta have a pen here. If I lined it up like this, I just did this instead, x squared plus negative 1, and then I lined up the next one, and I said negative 3x plus negative 2, and then I lined up the next one underneath, and I said 2x squared plus negative 4x, and I tried to add those together. How would that work? Does it look good? Are the like terms lined up nicely for us there vertically? No. So it makes it harder to add it that way, doesn't it? So that's why we do the placeholders, and I don't know, I just can't come up with another way to explain how we know where to put them. If a piece is missing, then you have to have it there. You have to put something as a placeholder there. Okay, we're not gonna do this one horizontally because I'm feeling pretty confident you guys can handle that, right? Could you do that one on your own? Anybody wanna do it with us? Should we do it? No? Okay, let's go to the back. Okay, we're gonna solve an equation that has some polynomials in it. Do you think we can do it? Uh-huh, we can. Okay. We have the equation b squared equals a polynomial happens to be what kind of a polynomial is 3b squared plus 4b plus 7? What kind of a polynomial is that? Cameron?
Quadratic trinomial.
A quadratic trinomial. And we just happen to have to subtract from that another quadratic trinomial. Okay, well we're gonna, you know what we're gonna do is we're gonna just bring this b squared along for a little bit. And then we're gonna do just like we were doing on the front. Any subtraction we have inside our polynomials, we're gonna change to add the opposite. Well, the first polynomial doesn't have any subtraction. Leave that subtraction alone for now and change the subtraction inside the other polynomial. We just had one subtraction to do within our polynomials to add the opposite. Now, we will take care of the subtraction between them. We'll bring b squared along again. Our first polynomial is going to come along. And now we'll change that subtraction to add the opposite of all the following polynomials terms. All of its terms will change to their opposite. So it's going to be what? Trey, tell me what's the second polynomial's new name now?
Negative 2b.
Squared. Okay, yeah.
You want me to say the whole thing?
Yeah.
Negative plus negative 5b plus 2.
Thank you, good. Now, this would be a good one to use the horizontal format because we have that b squared equals that's tagging along with us. So let's use the horizontal one on this one, okay? So we'll get some more horizontal practice. We get to ditch the we get to ditch the parentheses. And then we're going to, in the next step, rearrange them. Or, this is only if you can make this work and you can do it neatly. If you're like, you know what, I would love to use the horizontal format, but you're sure making it a whole lot of work, LeGrand. If you have a method of, like, you pick different types of figures, of showing like terms, I'm going to circle the b squareds because they're like terms. I'm going to put a rectangle around the b's because they're like terms. And I'm going to underline the constants because they're like terms. If you don't want to do the rearrange thing and you want to do that, I think we might be ready for that. Okay, go ahead and finish up that right side. Let's get, what does the right side simplify to?
B squared plus negative b plus 9.
So that b squared that's on the left side comes along. So b squared
Plus negative b
plus negative b
plus 9.
plus 9. Brighton?
Wouldn't it be negative b because it's 4b?
We do have a
minus
negative
5.
b here.
Oh.
Negative 1b, you want a 1 there? Okay, we can do that too. Okay. How are we going to solve this? What do you think? Cameron? This is like a challenge problem, you guys. Come on, we can do this. What do we have to do when we are going to solve equations? We have the same type of term on both sides, don't we want them only on one side or the other? What is there that's in common that's on both sides here? B squares. Let's get those, let's get B squares on one side or the other. Or maybe something else will happen. What do I have to do? Let's get them moved off of this side right here. What would I have to do to get those B squareds moved? Subtract them. If I subtract them there, I gotta also subtract them on the other side. Well, now we're doing some vertical. B squared take away B squared. 0. B squared take away B squared. 0. Well, we do them when we do that. We just go like that, don't we? When we're solving equations. Okay. And then we have a negative 1b plus 9. Okay.
Is that all?
No, we're not done. We gotta solve this for b. What do you think we should do next? What would be a good move? Do what? Add what, Malcolm?
0 to 9.
You want to add 0 to 9?
I mean, negative 1b.
Okay, so to get that negative 1b out of there, we would add its opposite, which is 1b. Yeah, just a b. So we're going to add a b, because what we're going to do is we're going to get the b's moved over to the other side. What is 0 plus 1b? 1b. And if you want, could we ditch that 1 even right now?
Yes.
Yeah. 1b is b. And then equals, what's left on the other side? 9. Hey, we just solved this. B equals 9. That value for b would make our original equation true.
Can it ever change? Like, is it always gonna be the number to your right side? All the way to the right side?
No, it's always going to be whatever is left after you can't simplify it anymore and the variable is by itself on one side or the other.
So
And
like,
it's not a b squared anymore, it's just a b or...
from up there, like, from b squared equals b squared plus negative 1b plus 9, would you already know that the answer is going to be 9, or would you change it?
No, we don't already know it because we had to do a little bit of more working it around and get it there. But that is the only answer we could get out of this one. We're going to learn later, but sometimes there is one.
There's no like shortcut to it, like you can't just say, oh, lines.
No, there is no shortcut to that.
So it could change, it could be something else, the answer could be something else.
Can't change for this one. So there's no way necessary for us to shortcut it to be like so smart that we say, way up here we say, you know what, the answer is going to be 9. I don't think we're going to know that. I don't think we're that good yet. Okay? Any other questions or concerns?